All right, guys, we are back. We've landed at the bench. Not our normal bench. It's over there. We're gonna work over here today. Today, we're doing a 4R100 transmission teardown. This 4R100 came to us out of a 2000 Ford F-150, not an F-150, F-350 with a 7.3 diesel engine. One of the easy ways to identify that it came behind a 7.3 is the type of bell housing. On the 7.3, the top of the bell housing is a lot taller and has a higher backbone coming up the back. All of the 6.0 or 5.4s or anything like that will have a rounded bell housing without this giant square on top. One of the big identifying features of a 4R100 versus an E4OD is the speed sensors that are located at the front and at the rear of the transmission. E4OD looks very similar to this transmission, but it does not have these two speed sensors. So, quick way to find out if you've got an E4OD or a 4R100. If it has speed sensors, 4R100. If it doesn't, it's an E4OD. We're going to take this thing apart and discuss what we find and how we would fix it. This unit came in with a no reverse complaint. We know that the transmission was worked very heavily through its entire life. The guy that drives this vehicle is known for hauling dozers, skid steers, so on and so forth. So with that being said, we're going to take our tail housing off, our neutral safety switch, pan, valve body, and start on the main case. One of the things that we're going to start with though is the neutral safety switch. Neutral safety switch has a lot of problems on the 4R100. When this fails, you can have a multitude of different codes, and you can have hardship complaints, or you can have delayed engagement complaints, all sorts of different stuff. So anytime I build one, I like to replace the neutral safety switch. Just my own preference, but that's what I like to do. So we're gonna get this yanked off and pull the tail housing off and see what we got. You don't hear that thing bounce off the bottom, you got a problem. 1.170. Let's blast all 4 bolts out. You can take a vacuum tester and test each valve. The lip seal off the side of it and destroys the piston. See if we got enough tools. Once you take the 2 bolts out, this guy should just kind of wiggle off there, like so. Going to pull our output speed sensor out. Got a little bitty short bolt. On the entire transmission, these 2 bolts are the only bolts that are this size. So keep that in mind. There's a lot of them like it, but not just that one. My tools keep trying to roll away from me. I don't know what to do. Put some brakes on them or something. This bolt is going to take a minute, just a heads up. But I got my hammer. Anywho, we got the bolt out. Oh! Almost lost it there. Get that out of the way. Let's see what we got. Going to remove the parking mechanism. I typically do not loosen the bolts back here until later on. You can slide this parking pole out like so. And time to get to the fun stuff. Pull out the input speed sensor. Oh no, it's bleeding. That's not good. There ain't no fluid in it. That's why it doesn't have reverse. Ain't got no fluid.
We need 500 cc's of A positive.
Yeah, 500 cc's ain't gonna be nearly enough for this guy. All right, take out all the pan bolts here. Thought I heard a vehicle, but I might be losing it. Ta-da! Train pan. Well, we definitely have an issue in here. There's not supposed to be a 1/4 inch of metal on the magnet, so definitely not, something not right inside it. Let's take a look. Get our filter out of the way, get it greened. Gotta get all the nuts. Got all the nuts. Don't want to forget your nuts. It's not good. One more socket size. All right, now that we have a cajillion bolts out, pick all these guys out of here. How many bolts can we put in a valve body? Let's start writing music. Transmission times.
That's the name of the first album.
Yep. It's gonna be a good album. It really is. Okay. So we're going to start with our accumulator body. The accumulator body has a lot of small issues, but we're going to cover as many as we can here. Some of the biggest issues that we see in the accumulator body are these valves that are way down in the bottom here. You see that one moving, see one right there, there's another one right there, and then there's a valve right here. So this valve is the regulator valve for this accumulator. If this valve gets hung in the bore, it will not shift. If the accumulator spring inside of this end of it breaks, you'll have an extremely harsh engagement. So a lot of times whenever we build these units, we like to pull each one of those solenoid regulator valves out and change it to a steel valve. That'll prevent the valve from getting stuck in the bore, causing random shift complaints. The boost valve, which is right here, comes out with removing this clip. Pull that clip out of there, and then you have to actually work this sleeve outward. I usually will try to use a pick or something to get it to move a little bit and then just slowly work the valve out. See if I can get this one to pop out. Sometimes it'll pop right out, sometimes it won't. That one's gonna be stiff, of course. Oh, gonna have to work that one. What I wanted to show you there, this boost valve that goes in this cavity will actually wear out inside. When this sleeve wears out, it'll actually wear the boost valve sideways into the bore of that sleeve. When that happens, you'll have erratic line pressure, you'll have random gear starts, and you'll have a lot of slipping complaints. So we always put new boost valves in. On to the main control body. Here's where it gets a little dicey. E4ODs will use anywhere from 2 to 4 check balls. 4R100s have the same problem. You have different levels of check balls. We've got one large ball, one small ball, small ball, small ball, and then another large ball. So whenever you're disassembling or whenever you're reassembling either one of the biggest things to look for is the holes in the plate to verify that there's supposed to be a check ball in that cavity. If there's not 2 holes there, it does not take a check ball. So I'll lay this off to the side, get to our main control body. Gonna flip our balls out. I like to save those for later. This is a early design valve body. And one of the problems that we see in this casting, the RFF6 casting, is this spring breaking. So anytime you're building one, always check this spring. I always like to replace it just because I'm a weirdo. So, but I'm okay with it. Get our solenoid block off of here. These things can be kind of stuck sometimes. I do not like to use a hammer on an electrical component, but I'm replacing the solenoid block, so I'm going to use a hammer to knock this thing out. Anytime we rebuild a 4R100, we always replace the solenoid block. That's not good. That separator plate is stuck. Come on, turkey. All right, giant separator plate. The EPC relief is in this pocket. There's also a little check ball that goes with it. That guy right there, and it sits in this location, just like so. I'll lay that in our small parts kit over there. Get our servo out. Now we can start taking some guts out. Let's see what's inside of this little turkey. To remove the front pump, we are using a 10mm socket. Now we can take our pump out. There's a couple of different methods to taking a pump out of a 4R100. I've seen a lot of individuals take a screwdriver and put it behind the back of the channel casting like this and smack this with a hammer. I don't like to do that on a 4R100. We actually use a pump puller. I think it's safer and ultimately works better. There are also threaded holes in the 4R100. Another way to take them out, I've seen this done a lot of times, is to thread a extension housing bolt in, like so. You haven't seen this trick, have you?
I don't think on this.
Huh?
I don't think on this one.
I haven't done it this way for a long time. This is the way that I was actually taught to do it. Use a crow's foot and wiggle it out. So,
You don't have that tool?
don't have to have this tool if you have one of these. So, just a different way to do it. And all you need is an extension housing bolt. Now, get our pump and shaft out. Don't drop your shaft. This thing is very delicate. You don't want to damage it. Nobody likes a bent shaft. Just telling you. It's not a good time. There is a Torrington bearing that rides on the back of the stator itself. Goes just like that. Outside race faces down. Just gonna leave that there for a minute. We'll get to the pump here in a little bit and talk about it. But going to get our coast clutch drum out and our overdrive sprag, overdrive planetary system, and then our overdrive clutches. The overdrive clutch is retained with a giant snap ring. We're not going to get descriptive, it's just a big one. And then these are the overdrive clutches themselves. They really don't look too bad for a guy that tows a lot. I expected those to be a lot more damaged. One common issue on the 40100 is this snap ring popping out. So anytime we are building one, we always replace that snap ring. They make a spiral lock snap ring, goes really well right there and does an amazing job. Same thing with the snap ring on the inside of the coast clutch drum. This snap ring likes to pop out. There's not a lot of tension on it. And when it does, it will damage the spring right here. So always replace those two snap rings. As far as the coast clutch itself is concerned, these things really don't look that bad at all. They're in really nice condition. Our sprag is in good condition. It hasn't laid over. All of the rollers are still free and all the springs still retract. So sprag's in pretty good shape. We're gonna set this to the side for now. Take a look at our overdrive planet. Pull this hub out. This bearing is a service item. Always replace your Torrington bearings. 4-pinion front planet. We'll check the planet for axial play between the gear and the roller itself. As long as we don't feel any axial play in it, usually the planet's in pretty good shape. But this is just a basic inspection to verify that the bearings inside of the gear is in good shape. The other side, to get the retainer plate out, you have to pull the snap ring out of the top. This line is actually very critical. This side is a machined surfaced side. It's actually ground flat. This side is not. This side against this washer will damage the washer. So whenever you put this together, this side has to be facing away from the plastic washer. Alrighty, who wants to see deeper inside of there? You want to see deeper? You want to go deeper?
Yeah.
Let's go deeper. Alright, well, we got to get this big snap ring out. We've got another one, just like the overdrive snap ring. We'll reach in and press the snap ring. Once we get our snap ring out, I'm gonna get that pump gasket out of the way. That's driving me nuts. We can pull the 3 bolts at the top of the case, and the overdrive and center support will pop out of the front. If you grab a hold of it and it doesn't automatically wiggle out, you can take a end of a hammer and just kind of tap on it. It'll recenter the housing into the case, and it slides right out. This Belleville Spring is another major wear area. Looking at the tips of the teeth, there's a groove right here that's not supposed to be there. You should not see a groove in the tip of the teeth at all. This needs to be replaced. Time to pull out the center support. Gonna have a nice little discussion here. I don't know how good we can zoom in right here, but you see the groove right here and right here. This is actually from the case itself flexing and this center support rocking inside of the case like this. What that does is it allows the direct drum to rock on the back of the support, and it causes this support to wear into the case and wear into the support. It's a really big problem. That movement allows the output going through it to rock as well, creates in play, and it creates axial movement inside of the transmission. So that is a huge wear area. Anytime we rebuild these, we like to replace this support with a new support and a new steel ring that goes behind it. They actually sell a machined center support with a snap ring to go on this side that'll help carry the load of the support in the case. So play that to the side. Pull out some more parts. We're going to disassemble this stuff, but first we must take a break. The gloves are on. Okay, anywho, back to what we were doing. We were in the middle of pulling this thing apart, and we are going to go to the intermediate clutch, which the intermediate clutch is in really good condition, which is kind of surprising on a 40100. The 40100 is a lot different from the E4OD in the intermediate clutch. It's one of the biggest areas of change that they made. So on the intermediate clutch on a E4OD, you will have a thick pressure plate, 2 thin steels, and then a thick steel on the backside. On a 40100, you have all 3 of the same thickness steels and 1 size of pressure plate. If you mix this up and put a E4OD stack in, it will not work correctly. Trust me, I've done it once or twice. This one actually looks pretty good. So we're gonna set it to the side. The intermediate sprag needs to rotate counterclockwise and lock clockwise. Rotates counterclockwise, locks clockwise. The direct clutch, which is down inside of here, is our next place to stop. Wow, look at that. Direct clutches are in beautiful shape as well. But we're gonna stick them off to the side. We're going to take our spring compressor, snap press, whatever you want to call this in the turkey. Get that guy positioned. Grab some snap ring pliers and pop that guy out of place. Some of the major areas of concern are the lip seal down inside of the drum right here. This lip seal can actually fold and create a major leak, or the outside of the piston will wear from the piston rocking inside of the drum. This one actually is in pretty good shape, so kind of surprised. One other big area on the direct clutch is the bushing on the inside of the drum. Anytime your center support is flexing, that bushing is getting wore plumb out. So always replace the bushing. Take a look at our sprag. Get our little plastic thrust washer out of the way. This is a dog bone style of sprag. The teeth, or the dog bones, are already starting to show wear. There's a flat spot right there on the side of the dog bone. I don't know if we can zoom in on that or not. It's gonna be kind of tricky. That's okay.
There it is.
Beautiful. So we'll be upgrading this to a larger element and a better quality sprag. And we'll move this stuff in. I'm not gonna go too far with that drum. We're gonna talk about some other stuff. Remove our band out of the bottom. And the forward drum. The forward drum, ooh, this one is about wore out. Shine it up to the light right there, see if you can see the major spline wear.
It does not look good, sir.
It does not. So what happens a lot is this shaft coming in, comes in from the back, like so. You can see I can rock the shaft inside of the splines. It should not be able to rock. The full spline drum, which is used in an E4OD, has splines all the way to the back, which helps carry the load of this shaft a lot better. So we will be upgrading this drum to a full spline instead of a half spline for our 100 drum. One of the things to look for when converting to a full spline drum is make sure that it has a bearing on the backside and make sure that it has this machined shoulder for the bearing to ride on. This thrust washer tells us that the type of sun shell that we are using. The 4-tab thrust washer goes on the face of the direct drum and it prevents the sun shell from coming forward. All right, take a look inside of this turkey. Woo! Pull our snap ring out of the top, lay it to the side. The forward clutch is stacked with a pressure plate, a wavy spring, and then a flat steel, clutch, all that kind of stuff up top. So we're going to lay this stuff off to the side and remove the snap ring that holds the Belleville Spring in behind it. Sometimes you got to use 2 picks. You can't be too picky. Snap ring to lift up a little bit. Pull right out. Remove the Belleville return spring. Remove the bearing out of the bottom. And then this piston should come out. If it's not stuck, it's stuck. Give me Going to have to get a blowgun. Blow that thing out. And inspect the inside of the piston for wear. Now that we are done with that one, on to the next one. Let's go deeper. We're going to pull out the front planetary rain gear, check for rocking in the hub, pull out the Torrington bearing, front planetary, sun gear and sun gear shell. And now we're down to the bottom planet. We're going to remove the inside snap ring, low planet, then we have another snap ring. Try to rotate this to where we can see it. Right here. That is retaining the output shaft. Remove the thrust washer out of the way. See if I can get my hands to work. Get a different pair of snap ring pliers. I don't like those ones. Ta-da! Get that out of the way. Now we can remove our outside snap ring. See, okay? See. We're going to pull our output ring gear out and our low sprag. Low reverse clutches, and they actually look like they're in really good shape as well. I still have yet to find the no reverse in this thing. It was very interesting. Wavy steel. Now we're going to go around to the back side, pull the shaft out. And we can remove our last piece. To remove the, oh, all my balls fell out. It's okay, I got extra balls, we'll be fine. We're going to pull the 5 bolts out for the low reverse retainer. Caleb, you want to come back over here? We are going to blow air into this port, which kicks the low reverse piston out of the back of the case. Still no sign of failure. Very interesting. Get our spring packed, move it out of the way, and the low reverse piston. The last thing that we're going to discuss here while our balls fall out is the case bushing. From this angle, the case bushing looks like it's in pretty good shape. But if you look at the bottom of the bushing, you'll notice a shadow in the bushing. Right here, there's a shadow, and right here, there's a shadow. The reason that there's a shadow is the output shaft rides in this bushing its entire life with the weight of the transfer case and everything else just hanging back here, and all of the load of the output of the transmission is carried on this shaft through that bushing. So anytime we're building this, we'd like to put a one-piece Sonax case bushing in to prevent this thing from wearing through the back of the case. So now we're at the bottom. That's it. There's nothing else left. We finally have the transmission torn down, and it's not looking so good. It definitely has some wear and needs to be rebuilt. So we're gonna get this one washed up and move on to the next one. Thank you guys for watching as always, and we'll see you on the next one.